Okay, so this is day 2 of graph to equation. So we were looking at this equation yesterday, and our goal today is to figure out how it's going to be graphed. So if we think about what we talked about yesterday, we know that we need to find the x-intercepts of the graph and the vertex to be able to graph it. So let's think for a second, what is an x-intercept? Go ahead and write x-intercept in your notes. Think about that for a second. Well, it should be something like this. If we have a parabola, it's these little spots here where the graph hits the x-axis. And what do we know about these points? Well, we know that y has to be 0 at them. We just got to figure out what these other numbers here are. So kind of like if we were doing a table, we want y to be 0, and we need to find the x values that go with that. So when we found the y-intercept, we put in 0 for x, and we would put 0 for x into our equation and calculate it and get out the y value. This time we want y to be 0, so we're going to put in 0 for y, and then we can solve this from here. Then we got to figure out how are we going to solve this. So based on what we were talking about yesterday about the zero product property, we can kind of do that here. So think about this. This right now is a sum. How can I turn this into a product? Well, this is what we've been doing in class with factoring. Factoring actually is the process of taking a sum to a product. I'm just going to go ahead and factor this really quickly for us. We know that that has to be 2x and x, and we know these two numbers have to multiply to equal 12. So I'm going to try 3 and 4, and I'm going to do a negative, let's see here, I'm going to do a positive 4 and a negative 3. And if we just double check this, 2x times x is at 2x squared, negative 3 times 4 is negative 12, negative 3 times x is negative 3x, and 4 times 2 is 8x. So negative 3x and 8x is 5x. So we're good. Okay. So if we think here, we need the numbers so that when I put my number in here, y comes out as 0. Because that's what our goal is. We're trying to find what number of x will make y 0 so that we can find these spots here. So if we think about this, if this number, because this is one quantity right here, times this quantity is 0, what do we know about either this quantity or this quantity? Well, we know that one of them has to equal 0, or both of them has to equal 0. So any idea what x could be so that this whole thing would be 0? Well, x, maybe if this one wanted to be 0, could be negative 4. Because if I think about it, if I put in negative 4 plus 4 is 0. And 2 times negative 4 is negative 8 minus 3 is going to be negative 11. And negative 11 times 0 gives me 0. So that works. So negative 4 can go into our table. But there's also another number that will work. If I look here, if I put in the number 1.5 right here, 2 times 1.5 is 3. And 3 minus 3 is 0. So this would be 0. And whatever that is, 0 times this will equal 0. So there's actually two things in my table, 0 and 1.5. And if we think about it, how do these numbers here relate to this equation here? Well, if they make this equation 0, they're also going to make this equation 0. So we have our little points here, and we can put our points at negative 4, 0, and 1.5. And now we can graph it, right? Well, this one's already kind of sketched, so I'm going to draw the one because that's actually not what that looks like. So if we have negative 4, 0, and we have 1.50, we can draw our parabola, right? Well, not really. We got to know, does it actually go this way or does it go this way? Well, one thing we figured out yesterday was that parabolas reflect each other. So we know that the vertex is either going to be, somewhere along here in the middle of these. So if we think of a number line, we have the number negative 4, and we have the number 1.5, and we want to find the middle of it. Well, how far is it from here to here? Well, it's 4 from here to here and 1.5 from here to here, so the full distance is 5.5. So how far is it from an endpoint if we want to go halfway? Well, halfway, this distance should be 2.75, and this distance will also be 2.75. So if we think about it, what is 2.75 spots in front of 4? Negative 4? Well, 2 spots in front of negative 4 is negative 2. And if we go another 0.75, we're going to be at negative 1.25. So if we look up here, we need to have our other points at negative 1.25, 0. And that's where our line of symmetry is going to go. And we know that our vertex is going to go somewhere on that line. Well, I don't really know that it's there. I just know that it's somewhere on this line. So I know that the vertex is going to have negative 1.25 something as my point. Well, how am I going to figure out that? Let's think about it. If we have a table and we put in negative 1.25 for x and I want to find the y, how do I typically find the y? Well, I go back to my equation again. So if we put in our numbers, 2 times, oops, I don't want to write x, 2 times negative 1.25 squared plus 5 times negative 1.25 and subtract 12 from it, then we'll get our number, and I don't have a calculator out with me right now, so you're going to have to calculate this. So you're going to get your number, and that goes right here, and whatever that point is, I can now make my parabola. Okay. I'm going to do one more example. And if you can pause the video at all and try this on your own, that would be awesome. So if we have the equation y equals x squared minus 2x minus 8. Okay. Well, we know that it's going to need its x-intercepts. So that's where y equals 0. So if I had my table, x and y, I'm saying y equals 0, I need my x. So if I put in 0 for y, I need to figure out my x's that make that true. And if I factor this into x, and let's try 4 and 2, and that factors there. So what x's is going to make this true? Well, if x was negative, or if x was 4 and x was negative 2, then I would get 0. And if you're not sure, try that. This should be true in our table. So if I put in 4 for x, 4 squared is 16, minus 2 times 4 is 8, so 16 minus 8 is 8, minus 8 is 0. It works. And if I also try negative 2, negative 2 squared is 4, minus 2 times negative 2, so that would be 4 minus 4 is 0. Nope, 4 minus negative 4 is 8, minus 8 is 0. So we would get that also. So then we know these are our x-intercepts right here. So we can go ahead and sketch our graph at negative 2, 0, and 4, 0. And then we know our line of symmetry is going to fit halfway between them. So halfway between negative 2 and positive 4. Well, if we think about that on a number line, negative 2 is here, and 4 is here. And the distance between these two is 6. So half the distance would be 3. So 3 spots back here, that's going to be 1. So we're going to have our line right down here. The x value is going to be 1. How do we find the y value? Well, think about it again. If we put 1 in our table, how do we get the y? We use our equation again. 1 squared minus 2 times 1 minus 8. So 1 squared, we will get 1 minus 2 minus 8 gives me negative 9. So this is here, and we can draw this.